So within discrete event modeling, we might have a process like this one we built last time. People remember this, right? Within discrete event models, we have a well-defined process that's not necessarily linear in character. It could have branches. Indeed, ours does at Q. Does anyone remember what this branch represented? Where one goes up and above, one continues on. What was the word I used for it? Balking. These are individuals going sort of up there that basically chose to leave because the waiting time was too long, and then others continued. So we have these processes depicted in these kind of flow charts. They can have loops, they can have splits, they can be fairly involved, but fundamentally you do need a process that's fairly well defined, that isn't totally fluid. So that's one feature. We have entities, which are the actors or the quantities that flow through these systems. So in this case, they start at the source and they flow down. And a lot of these operators within the flowchart, they basically exist to operate upon those entities. And typically, to flow down through that flowchart at one or more places, the entities will require, in order to proceed, a resource. Give me a couple examples of resources. What might be required? Okay, good start. How about other resources? Yeah, doctors, clinicians of various sorts, etc. But let's think about other types of resources. Sorry? Okay, an operation room, a fixed piece of infrastructure, right? A piece of testing equipment, an X-ray machine or something, a robot to help install a certain component of a car. Okay, and how about a different sort of resource? Well, there's another one called a portable resource within AnyLogic. That's something that doesn't have agency by itself. It can't move by itself to the entity, but it can be carried. It can be carried by another resource. It's called a portable resource, compared to a mobile resource like a doctor or a nurse, compared to a fixed or static resource like a room or an MRI machine or what have you. So we have, within discrete event modeling, these processes, these entities which flow through the processes, these processes in fairly defined and sometimes rigid sort of flows. We have entities that flow through those processes, those sort of workflows. And then we have resources which are needed to allow those entities to flow through. Now, what happens to an entity when that resource is not available? So they come in and there's no nurse available. What happens? They wait. Milton said in Paradise Lost, they also serve who only stand and wait. I saw that once on an ad for a bank, advertising short lines. And if a resource is not available, a person waits. And in some cases, we may want to indicate that the person has limited patience. In other cases, maybe they're just a car chassis waiting for a robot to be available. They'll wait as long as required. Great, so we saw this sort of modeling. And indeed, I asked you to watch a video which explained components of this modeling, which explained operators within the modeling. And I could sit here and I could quiz you about those resources, but I've elected not to do so. Some of the students in this class informed me that there was a competing class which had tests today and exams today. So I promised that I would not give a pop quiz today. I promised to them. Sorely tempted. Alan would have been ready to serve. But I elected not to do so to spare you, because some people apparently are out to take this exam in another class. So it is. let's go start with this model, and now let's elaborate it to include something else, which is a very important component of this sort of modeling. It has to do with what I termed last time something like the endogenization of travel, time, and paths. What do I mean by that? Fancy terms. Endogenization of travel paths or travel time. What do I mean by that? Do you remember what we meant when we said a model has certain quantities that are endogenous versus exogenous or ignored? Exogenous things are things the model may represent, but it's just told in a fixed way what to represent. There are things which are totally ignored in the model, left out. And then there are some things which are endogenous. What does it mean for the model to have something endogenous? Or to, calculated within the model, generated within the model. We can't tell it, make this happen. It's generated as part of the model. So those SIR models we started with a while back, there the number of infections over time is endogenous. We don't tell it, make this many infections happen at week 1, week 2, week 3, exactly. It generates that from the assumptions. And in general, when we endogenize things, we gain a certain flexibility. And we can ask what-if questions. What if we were to change this or that? How does it affect that thing which is generated, right? We can run these experiments and sort of see how does it affect the endogenous quantity, the thing that's generated. So we could ask, for example, if we had fewer contacts per person, or, so people were asked to stay home, schools were closed, how many infections would result? Here, we have the option with this sort of modeling of not only asking about resource availability, how would the number of resources available in the form of nurses affect the flow of patients? How would it affect the fraction that bulk versus that go down this main flow? But we could also ask, how would the placement of resources, the layout of the facility, affect things? But we didn't see that last time with our model because we didn't get that far. But we will today. We will today. So goal 1 of the model is to show you how models like this can capture visual resources, can reason about travel, and so on. My second goal today is to show you parameter variation experiment, which will get you all the way you need to go for problem set 3, for problem 3 of problem set 3. Okay, so ladies and gentlemen, let us start with this. And let us copy now. Let us go save this model, save as, and let's call it DES2, Discrete Event Simulation 2. And I'm going to say in class, okay? Because between people's coming in for office hours, I took the luxury of putting it through its paces myself. So make sure the model time is in hours. And we have all these features of the model. We're going to build the top of this model. We're going to extend it. Okay? Great. So, ladies and gentlemen, what I'd like you to do is to go and we're first going to put in place a logical representation within the model of an additional type of resource, okay? And this resource will be a procedure room. So we need to allocate a procedure room is the idea for each person within the model, okay? Okay, so we're going to get to a visual representation of those procedure rooms in just a few minutes. But first, we're dealing with the underlying logic, the underlying sort of allocation of resources. Soon enough, we will factor in paths, and that will allow it to endogenously calculate how long does it take for a patient or a nurse or whatever to get from A to B, and that will affect how many people can go through this model, how quickly. But right now, we're going to deal with the logical allocation. Okay, so what do we need to do if we want to add another resource? Anyone? What would we need to do? Okay, good. Need to add a pool, but add a pool of what? Add a pool of procedure rooms. Okay, that's great. So first, we actually need to do, just as Arlen said, we're going to add a pool. But first things first, we're going to add a resource type. Okay, so go up to this, again, this model here, which is a process modeling library, and drag resource type over there and create procedure room. Okay? And we're not going to have any animation associated with this. And you can just say finish. Okay? So here's our procedure room. That's step one. Okay? Okay, so here we go. Here's main. Step two, just as Arlen advised, I would like to drag in a resource pool. This is a pool of these procedure rooms, so let's call it procedure rooms. Okay? So we dragged in a pool of these procedure rooms, and for the resource type, I'd like you to tell me which type of resource do you think this needs to be? Anyone? What sort of resource? It's static. Yeah. It doesn't need to, it's not moving around, and it's not portable. Okay? Now, we're going to come back to this, but we're going to leave this capacity defined as directly at the moment. We're going to say capacity is 4, okay? And we're going to say the new resource unit is a procedure room, okay? Great. So new resource unit procedure room. Now, Alan stands ready to serve here. So just raise your hand if anyone has trouble. So what I did is I went and I dragged in from here resource type, I called it procedure room. Didn't do anything else there. I said finish, no animation. And then what I did is I dragged in from down here the resource pool, and having done that, I then went and I set it to be a static resource, capacity 4, new resource unit, I said to make procedure room. You okay with that? You'll notice down at the bottom, it also says procedure room. Okay. Are we okay? We ready to go forward? Okay. Now, ladies and gentlemen, having done that, I would like to go up to this block here, which is labeled currently assign nurse. Okay? And you'll notice that right now, this is called assign nurse, and it's saying, okay, what is the resource pool associated with this? Okay? We're instead going to say C's alternative resource sets. Okay? Here. I'm just going to double check something because my memory was a little bit off as to how that's done. Yep, that's correct. C's alternative resource sets. So these are different resource sets needed here. And we're going to add these resource sets. We're going to add in one nurse as being needed. We don't need to change it from the default. And we need one procedure room. And you notice that we can have a C's policy, which either seizes the whole set at once in a transactional manner or seizes units one by one. What do I mean by seizing the whole set at once in a transactional manner? Anyone here taken 355? One person? Did you cover transactions in that course at all? Okay, so what does it mean for something to be transactional or atomic, more specifically?
Like a transaction?
Yeah.
It would do either the whole transaction once or not at all.
Or not at all.
It would do many simple operations all at once. If it fails, it rolls back and
doesn't do any. This is an extremely important point. And I hope you listened to what Evan, is it? Yeah, what Evan just said there. A very important concept. And for those who missed 355, I try to make sure that in my classes, at least 371 and 470, that students get exposed to this. Because this is a fairly fundamental idea in computer science that is absolutely key to helping computer systems work properly today to allow operations over the web to work properly. When we go and we buy something on Amazon, for example, we expect either, we'll purchase the thing, it'll charge our credit card, and it'll be shipped to us, or neither will happen. If it's not available, if it's out of stock or whatever, then they won't charge our credit card. The two have to go together. You don't want a computer system which does one and then realizes, oh, I can't do the other, but by that time it's too late to undo, or the computer system has a problem and it doesn't undo that earlier one. So either you want both to occur or neither. Even to the point of if the computer fails in the middle of the whole thing, it's either done both or neither. And typically if it fails in the middle, it's done neither. This may sound hard to implement, and it's not trivial. There's a science behind it. There's a whole theory of transactional systems. But it's key to making reliable systems work, even in the case of error, in the case of faults, timeouts on the network, or what have you. This is what we come to expect, right? We don't get charged if the service can't be given. And so it is here. We either want to seize the whole set at once, in this case, or we want to wait for both. We don't want to seize one, say seize the nurse, and the procedure room's not available, and then have someone else seize the procedure room and wait for the nurse, and for us getting a deadlock. We want to be able to either get everything we want or wait for both. We don't want to be locking the resources each other needs. Okay? We'll come back to that issue in 371 or 470 for those who will be in my other classes. But it's just one aspect of a computer science concept that's key here. So we're doing both. And where else do you think we might need to anticipate? Let's call this assign nurse and room. Okay? Assign nurse and room. Great. And for space reasons, I'm going to move this down to here below. Okay? And now, ladies and gentlemen, over in the release nurse area, we're going to say release nurse and room. And you notice we're going to say release all seized resources of any pool. That's what we want. Okay? That's what we want for us to proceed after we've done the workup. So we're going to wait for a nurse and room. We're going to be in this queue if we can't go forward. And then at the end of the workup, we're going to release the nurse in the room. Does that make sense? We need both resources to proceed. And there are going to be procedure rooms. I asked you to put in 4 for now. We're going to revisit that. For nurses, I'd like you to put in 3 for now. There's only 3 nurses available. Okay? It's a bit of a contrived example, but if we wanted to take it further, that would start to add texture to it. Okay, great. Procedure rooms and nurses. So let's build early, build often. Build your model. Alan stands ready. And now I'd like you to run the model. If it's a happy camper. If it's not a happy camper, we can you can raise your hand. Okay, so ladies and gentlemen, here we have an indication of resource availability. What is this telling us about the availability of resources? I'm running this model. Just by looking at nurses and procedure rooms, what do we see about differences in availability? There's normally a room available, one out of the 4 available. And how about nurses? They're all busy, which is in many environments very true. So the nurses are kind of the limiting factor here. They're the one who's totally maxed out. The procedure rooms, there's actually one typically available. Maybe it seems obvious in this case because we had 4 and 3, but again, in a more textured system, it will become more interesting. And also, once we take into account some aspects of traveling, where the nurses spend time moving, the procedure rooms don't have to move, this will change further. Okay, so now we have procedure rooms and we have nurses, and we can go in and take a look at statistics here within this context. You'll notice that we have, in the current settings, we have somewhat fewer people being served than we do. It's about half the number being served, a little bit less than we do bulking. Okay, great. So you got that working? Okay, now let us start to add more texture to it. I promised you that we were going to add visual elements to this model, and so we will. So, ladies and gentlemen, I'd like you to go to this process modeling library, and I'd like you to scroll down, and you'll see that in the space markup area, there's a set of elements here, which will allow you that we'll be using to sort of draw the system. So, ladies and gentlemen, I would like you to go, and we could lay this on blueprints and so on. We don't have that luxury here. I would like you to draw in a rectangular node here, and I would like to name this node. So waiting room, okay? And you notice there's a thing that says locations layout random. What that's actually telling us is that the people will, when we tell people to sort of go to that room or appear in that room, they'll appear in a random location within this space. Okay? Are you okay with that? Okay. Now, the way I'm going to do it, you can't really see it from where you are. Maybe you can. I'm aligning this with one of these big grid squares, and the exact size of this is not important, but I'm gonna put it so it spans 2 of these big squares or so. Okay. Great. Now, ladies and gentlemen, I'm going to draw a similar node over here and have it span. Just have it span like that. Okay. This will be called the nurses lounge. Okay. Great. Now, we're going to drag several other items up here, and they're all going to be of equal size, and this is going to be called procedure room 1. Okay, and I'll make it span sort of 1 unit down and a little bit more than a unit over. And I'm going to copy that to create 3 additional ones, okay? So there'll be 4 procedure rooms, okay? So 1, and you can rotate them, and I'm tempted to do that so that they kind of preserve their equal space. Hey, come on, get down there. Okay, there you go. Okay, there we go. Okay. Okay, and then we'll have another one here. Here we go, 4 procedure rooms. There we go. Okay. And what the heck, we'll put another one in. We have space for it. So there we go. Make it look more complete. Great. Okay, so here we have a little facility. This was called Nurses Lounge. This one is procedure room 1. We want to make these others procedure room 2, 3, 4, and 5. You notice that if you do copy paste, I did paste, 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 paste. You notice that it numbers them accordingly. Okay. How many people would like me to wait for a minute or so till you finish? Okay. Okay, you notice that I'm doing this through this rectangular node. I hope I emphasize that, but that was how I drew these things. If you want to draw a more irregular shape, you could use this polygonal node. Okay. A little bit more time, or are people ready to roll? Ready to go? Okay? Okay, sure. Okay. For those who would like to jump ahead, you could start to drag a path in and futz with it, as it is wont. So these paths are ornery beasts, but I'll show you a trick. Personally, I don't care for these paths that much, the way they're manipulated. But watch this. I just dragged the path in, and if you click here and you click here, you can render it into a straight line, which is more amenable to our machinations. Okay? Okay, so how did I do that? I dragged in a path, and then I just double-clicked along its way and shrunk it to a tractable size. Okay? Are we ready to go forward? Okay. Okay, so ladies and gentlemen, having done that, let me go through that one more time, this path. Let us render this into a more compliant sort. And now I would like to drag this path so that it spans this area here. This is going to be a path on which our entities and resources tread. Okay? This is going to be the path they take from one place to another. So I've just done that, and I'm actually going to copy it, and I should have copied it. What a travesty. Okay. I'm going to have to drag it in again, and I should have had the foresight to copy it several times over. Copy, copy, copy. Okay. Now, having copied it a multitude of times, I'll be able to do my bidding with it. Okay? So, ladies and gentlemen, I would like you to go connect it up another path up here, and then I'd like you to connect these areas to the periphery of these rooms. Note my actions. I drag this so it connects, as indicated by the green blivet. See that? Okay. And same thing, it's connected with this path here. And ladies and gentlemen, I'm going to take this one and similarly connect it so it's connected at that element. And similarly for each of these procedure rooms, I will connect it up, the rectangle up to this path. That will indicate how you can get from this path over which the actors will tread, how you can get from that path to and from the procedure rooms. So it's rather important for our purposes that it, oh my gosh, that it actually be, oh gosh, okay, this thing is exhibiting truculence. So pardon me while I fight with it. Okay, hey, come on, get over there. This is not a very uplifting activity. Okay, I just selected it, and now I'll move it over. There we go. Okay, that's mighty good. And I'll drag another vertical one, and I'll okay. Let's drag the whole darn thing. Okay. There we go. And okay, I'm going to drag another one of these over to. Hey, oh man, you won't even line up. Let's see if we can line this guy up. Okay. At the cost of a crooked line, I may have to give up there. Let me try manufacturing one more. Okay. Okay, and there we go. Okay, vertical line. Okay, and I'm going to copy it before it's lost. Hey, come on, get back there. Okay, and here we go. There we go. Okay, now we actually need one more vertical one going up to this, just to this area here. I apologize for engaging you in architectural sort of pursuits, but it will allow us to define the paths over which these agents tread, and in fact allow them to go from one place to another automatically. Okay, so we should see something like this. These paths should exhibit junctions as depicted, and they should be connected with these nodes. If anyone needs help, Alan sits ready to serve. Anyone need help? Okay. Does anyone want a little bit more time? Perhaps you're fleeter of fingers than I. Okay, great. So we're ready to proceed, ladies and gentlemen, to the next slide. We've actually done the hard parts here. What we've done is we've delineated the resources, to wit, a waiting room, a nurse's lounge, procedure room 1, 2, 3, 4, 5. And now what remains is for us to link them into the logic. That was the tedious part. And now the delight. Okay? Okay. So the first thing I'd like you to do, ladies and gentlemen, is to navigate to the nurse's area. For the nurse's area, I would like you to scroll down in this to select the home location and select nurse's lounge. The home location for the nurse's resource will be the nurse's lounge. For the procedure rooms, we will be doing something rather more articulated. So I'll wait until people finish with the nurses. Why are we doing this? Why are we associating? Why do we care visually where it is? Because it may be, in certain cases, movement times, placement of resources really matter for slowing things down. And if you change the location of the nurse's lounge to be more central, maybe it would shave some time off per day, save you half an hour a day in terms of movements, which might ripple through to, a couple more patients or something like that you can serve. If you care about placement of resources and travel time, this sort of mapping that we're doing turns out to be quite helpful, quite useful. If you care about trying to understand what the implication will be of different layouts of a facility. Imagine if Sphinx, the computer labs here, were not located on third floor Sphinx, but were instead down on the first floor Thorvaldsen. How would that impact the ease with which graduates could circulate or undergraduates? How would that shave time off your lives? This is the sort of modeling that could help shed light on that. Okay, so having dealt with nurses by assigning them a home location, we will now engage in the more textured aspect of defining the procedure rooms. So go down to the procedure rooms. Now, let me just ask you, suppose for the procedure rooms I said, okay, the home location is procedure room 1. Would that cut it? What would that be missing? Yeah, they're spread out. They're distributed. So we can't just say 1. So instead, we could list them one by one here, but in the interest of time, I'm going to use this button. I'm going to use the button here, which allows you to point and click at each of them. So see this button here? Let us now use it. Click on that, and it will allow you to select certain areas. So procedure room 1, procedure room 2, 3. Hey, get up. Okay. Okay, let's do that again. Procedure room 3, 4 rather, and 5. Okay? Did you get that? Okay. Next, scroll up, and where it says capacity defined, by the way, we could have done the plus sign there and added them manually. Capacity defined, I would like you to say by home location. And where it says based on attractors, say unclick that. You can define actually attractors, so you can have like multiple places you could go in a given room. These attractors would define sort of places that are of significance, but I uncheck that. So how did I do this? I clicked on this icon here to select each room in turn. That populated this area of the home locations. I then went up and said capacity defined by home location, and I unclicked based on attractors. Okay? Are people okay with that? Are you good with that? Okay. Great. Okay. Well, ladies and gentlemen, we're coming along. But if we were to run it now, we wouldn't see too much of interest. Why? Because nurses are not lent yet a face upon the world. Let us give them an image. Okay? So I'd like you to double click on nurse. And I would like you to scroll down to the pictures area. And at the cost of potentially displeasing some doctors online, I'm going to drag up the doctor icon for nurses, which is a bit more unisex as well it should be. Okay? So it's a doctor icon here. Okay, for nurses. Similarly, for patients, I will lend them an icon. And for that, I'll use the patient icon. Okay. So what did I do? I opened nurses. I went down to the pictures area, the pictures palette, which rests just below connectivity. And for nurses, I put in the doctor icon. For patients, the patient icon. I know some of you may be eyeing those forklifts and fighter jets, but I won't police you. Okay. Okay, so are you ready to move? Okay, so now let's build. Make sure things are hunky-dory. Okay. Build early, build often. Okay, it's compiling it. Good. And it seems to be a happy camper. It really should have. I should have selected just one so it compiles that project. And now I'd like you to run it. Okay. Here we go. Okay. We still don't see too much of interest, but we see the nurses depicted here. Okay. Why are the nurses there? Why are they in the upper right here? That's their home location. That's right. Now, patients haven't yet gone anywhere, and we'll get to them. So we haven't seen them. Okay, so the nurses are in their home location. Let us now, ladies and gentlemen, go to source. Okay, go here to source, and I would like you, in editing the source, to go down and scroll down in source to where it says location of arrival. And I would like you to pick network GIS node, and then for the node, select the waiting room. How did I do that? I went to main. I went to the source. I scrolled down. I went to location of arrival. And for the node, I picked the waiting room. Okay? Now, let's run this model, see what happens. What do you expect to happen now? Okay, there are these, who are these people that are appearing there? Are they appearing or disappearing or both? Both. Why do they disappear? And on what circumstances do they disappear? Well, when they leave the system. This is not like an agent-based model where people stay on an ongoing basis after they've left there. They've actually left the system. They've appeared here, and for the duration of time, they stayed there. Let us now remedy that, ladies and gentlemen. Let us remedy that. Okay? So, ladies and gentlemen, I would first like you to go to assign nurse in room. First, we're going to need to have the nurses come grab the patients in the waiting area. So I'd like you to go to assign nurse in room. And you'll notice within this that there are two options here. Send seized resources. I will select that and I will say the destination is indeed the agent. It's the entity that's flowing through there. And attach seized resources, yes. This resource will be attached to the entity. They will travel together subsequently. So if the entity goes to the procedure room 3, the nurse will travel with it, with that entity. Okay? Who would like me to show something that I've done? Who would like me to pause? Sure. So for this little bit, for assign nurse in room, I scrolled down and I checkbox the send seized resources, and then I did this checkbox attached seized resources. Okay? Okay? So now, ladies and gentlemen, what is this send seized resources? What do you think the function of that is? What's the job? What a job does that accomplish? What job does that accomplish, that you send the seized resource? The nurse goes to the patient. That's right. Okay, good. So what's happening now is the nurses go to the patients here. But then after that, they don't go anywhere else, okay? So we need to somehow get the workup room, to go for the workup room at a certain location. Now, could we just pick that the agent must go to a certain room, like procedure room 1, 2, 3, 4, 5 here, for the workup? Can we do that? Would that be what we need to simulate them going to their appropriate rooms? No, it's too rigid. We need them to go to the room to which they have been assigned. So how are we going to do that? Well, we need a new operator here, ladies and gentlemen. We need a new operator. So I'm gonna give this guy some space. Just give it a bit of room here. Okay? Okay, great. So I'm going to go again to this palette, and I am going to add in here a move to. Okay? Notice when you move these in, it very helpfully, if you move it into an area that's already connected, it actually connects it up, okay? So this would be moved to procedure room, okay? That will be the name of that. This is very important. Moving to the procedure room. So how did I do that? I went down here to the palette, I dragged down, and I chose move to, and I dragged it up, okay? And I called it move to procedure room. Okay, ladies and gentlemen, where do you think its destination should be? I've just chosen a list of possible destinations. In this case, where do we want it to go? Yeah, And so specifically the seized resource unit. And what resource? The procedure room. This is a subtle issue, and I want to capture this. I'm saying move to a procedure room here. Which one? One that I've seized, that's associated with me, that's been allocated to me, that's been reserved to me. That's what the seizing means. It's been logically associated with me. So I go to a certain location delineated by a seized resource unit, in which unit? The procedure room that's been assigned to me. So these operators are sort of defined with respect to the entity of interest. Does that make sense? So this is operating with respect to a particular entity. Where does it go? It goes to one of its seized resources. Which one? The procedure room to which it's been assigned. Different entities may have been assigned to different procedure rooms. When they reach this point, they'll each go to their proper procedure room. Are people clear about that? Okay? Okay. Now, time is a fleeting, as they said in Latin, tempus fugit. Okay? So I'd like you to run the model. Okay? So now we're having entities go to various locations in their procedure rooms. Okay? So they're making use of these procedure rooms. We could somewhat more artfully arrange it, but fundamentally there's movement going on here. And if we were actually to slow this down, and I'd invite you to do this, I'm going to actually go and slow the model down ahead of time and run it now and watch as the very first patient comes in. Well, actually, the reason for it is it's going incredibly quickly. Ladies and gentlemen, we have not really set what speed things move. So I'd like you to go take a look at the nurse. Okay? Go look at the nurse. Let's see how fast nurses move. Okay? Okay? Note how fast this nurse moves. Is that realistic? 10 meters a second? For the nurse, right? I just scrolled down, movement, 10 meters a second. Do you think that's realistic? That's a world record. That's like Usain Bolt or something. Flying across the room. Imagine if we had a TA like that. He'd be. So for the nurse, let's go to initial speed 0.5. Okay. Meters per second. That's kind of more. Okay, maybe that's, yeah, maybe it's more like 1 meter. Anyway, I'm not going to belabor it. And then maybe for the patients, well, some patients are slower, some are more light on their feet. Maybe we'll set them to an initial speed of 0.4 meters per second. Some are infirmed. Okay. Incidentally, this is a Java expression. We could draw it from a distribution, right? Okay. Who needs help here? Okay. Sure. And Wade, what would you like me to show?
I'm getting an error.
Okay. Sorry. Assign nurse in room. Oh, this guy here. Yeah, so what I said is that I would assign alternative, and I chose the resource sets nurses in procedure rooms. Under advanced, yeah.
No, it's right below it's the destination here.
Okay. So the destination is the agent. They're going to the agent. Those that are available to move, namely the nurse. Okay. Wait. So what error are you getting?
When I run the model logic error, root.move to procedure room, an agent is not able to leave the fourth room.
Okay. Okay. So that's something with this guy here. So let's just check, move to procedure room. It's moving to seized resource unit, so that looks good. Let's take a look at the pool here. So I'm investigating various hypotheses about what may be going. First, I thought maybe there was something wrong with that operator, then maybe something wrong with the pool. This is allocating a certain room pool. You're seizing the whole set at once. I don't see a problem with that. And are you freeing up all resources here? You're releasing all seized resources. So I don't see a clear problem. This is really interesting. Okay, we need to, I'm going to need to come back to you on this guy, but maybe you could pull up next to Evan and I'll look at that. Okay. Okay, so folks, if we run this now, what we should see is something along these lines. And I think in the interest of getting in the parameter variation experiment, I'm going to leave it at this. If I really want to flesh this out more, I'd have another move to after release nurse and room, where the patients might move back, for example, to the waiting room rather than just disappearing from here. The important point is there's actually movement going on here in the context of, in fact, if we were to go and start it, okay, excuse me, okay, and I want to run this thing, okay, this is 1, 2, oh, it's on full blast, okay, I don't want that. I want to run it at 1/250th of an hour, and I will, okay, so the nurses stand ready, and you will notice that there is movement going on along these paths in a fairly straightforward way. So in other words, as they travel, they do move up along these paths and between these locations. If we had a location where they had to fetch something from, we could examine the effect of shifting that around, and their travel time would be effectively endogenized. So they would be traveling, and their speed might vary on a per case basis in a way that would limit how quickly they could travel with the type of patient, etc. Now you'll notice that this has changed the resource room availability. Here we have resource room procedure rooms available, used about 58% of the time, nurses about 97% of the time. We have a somewhat different situation. Okay, so I've just shown you some elements of how to capture movement, how to capture locations, how to associate the movement with seized resources. What I would like to do now is to proceed to incorporate elements of the parameter variation experiment. Okay? Now, let me say a few words about the parameter variation experiment to situate you conceptually with what's about to go on. Thus far, when we have run these models, we have always run simple experiments that start up main, run main to the end, to its natural end, and stop. We examine a given run at a time. If we want to rerun it, say with different random number seeds, we can do so by telling it to choose a random number seed in simulation. But each time we're running it, it's for a single realization, a single run of main. The experiment and main are pretty much coterminous. They occur at the same time. The experiment completes when main has done its job, and that finishes the model. And we're looking at main. We're examining main visually. What we're now going to see is something very different, ladies and gentlemen. We're going to a different sort of experiment where the experiment outlives main. In fact, in the parameter variation experiment and in the calibration experiment that you'll soon be seeing as well, the experiment runs main many times. Not just once, but it runs main again and again and again and again. In this case, we're going to run it with different random number seeds. Our goal is to see how much stochastic variability there is, how much just chance happenings, how do those affect the outcome. In order to do that, the experiment will far outlive main. It may run main 1,000 times in the course of the experiment, running it again and again and again and again. Does that make sense? And each time, this is the key point. This, ladies and gentlemen, is the kicker. Each time it runs main, it does so for a reason. It needs to grab certain information about that run. Maybe it wants to collect the number of people that are infected over time. Maybe it wants to collect the resource utilization. Maybe it wants to collect information on how long it took from someone to get from point A to point B in the model on average over the course of that run of main. And it needs to salvage that information before main disappears. Because after all, it's going to be running main many times. So it's going to do one run. When that run is finished, when main is finished, ladies and gentlemen, it will extract that information. It will suck it out of main. And it will store it away in the experiment so that main can disappear and we can go on to the next one. It will run that one to completion, and once again, it will suck it out, store that information away, and run it again. Does that make sense? That's the conceptual model of what's going to be happening. And that's going to explain the next 10 or 15 minutes, okay? So the experiment outlives main. No longer is the experiment occurring, starting and ending at the same time as main. So, ladies and gentlemen, I would like you to take a bold new step. I would like you to go to File, and so make sure this one is open, File, New, and I would like you to add in an experiment. And this experiment will be a parameter variation experiment. You can leave its default value. Indeed, we'll need to be fleet of foot to capture what we want to do. So I'm going to say finish. So we've now added a parameter variation experiment. Okay, ladies and gentlemen, I would like to draw your attention to several features of this. In a parameter variation experiment, we have the luxury, and we'll be seeing this soon, for when we go and we're doing sensitivity analyses. We have the luxury of either running the model many, many times on its own terms, or varying certain parameters in the model in a certain range, from one value to another with a certain step. So maybe we want the contact rate from go to 1 to 20 with a step of 2. It'll go 1, 3, 5, 7, etc. Okay? Right now, for the purposes of this discussion, we're going to set it not to vary parameters and range. Notice that's blank right now because there's no parameters in main here for this model right now. We're going to set it to freeform, okay? And we're going to tell it we want to run it 50 times. We want to run the model 50 times. 50 times, ladies and gentlemen, it will start main. 50 times main will run to completion. 50 times it will rescue, salvage that data from within main to store it away for display within the parameter variation experiment. Does that make sense? That's what that number of realizations is about. Now, for each of these runs, we'll run it without prejudice to time 100. We could have set it to time 1,000, but I'm going to leave default values often so we can try to finish this exercise. Okay? Stopping at the specified time. Okay? Good. For each of them, it doesn't make a lot of sense to run it with a fixed seed. We'll run it with a random seed. Okay? Each time we run it, it will be with a new random seed. Okay? And actually, I should double check. This may be fixed seed, each realization will still run with a different random seed because it goes one to the next to the next. But in any case, we'll set it to random seed. It doesn't hurt. Okay. So this is great. So let's go run this. You want to run it? Okay. Let's go runner. Okay. So let's go run. I right-click on parameter variation, do run, and you'll notice that it's the most uninviting screen. But the key is to use this little button up here in the upper left. Okay, and take a look at what's going on down there. Oh, what's going on? Let's try that again. What do you think these represent? Those are actually, it's running on dual cores of my machine. This is a virtual machine. I'm actually running Linux, and it has 4 cores, but I've allocated 2 of them for this virtual machine. So it's running 50 simulations here. It's just run the model 50 times. Okay? So you're taking it from me on faith right now. I run the model 50 times. It sure looked like it was. How do we know that? Well, that brings us to the next step, ladies and gentlemen. Ladies and gentlemen, we will now set this parameter variation experiment so that it actually does something after each run. After all, we're running it, but we're not getting any information out of that run. We have nothing to show for it. Let us have something to show. Ladies and gentlemen, close this window. Okay? Now, this is where it gets a little bit more textured yet. Pay attention, because the keys to problem 3 or problem set 3 lie before you. Okay? Okay. So, call up the properties window here. Scroll down. And you will notice down in the Java Actions area, I will send a video about this beyond this one that will also explain this. But it bears paying attention. You notice there's a thing that says after simulation run. That, whatever you put there, that code, this is a handler to invoke certain code after each time main has been run. Now, I would like you to scroll over, or to mouse over here, and you'll notice it says use root, top-level agent. In a most cryptic fashion, what it's informing you there is that you can access everything in main through root. What it's saying is if you refer to root, it's referring to main. And that's your ticket. That's where you want to go to collect information. That's where we'll be going. But first, ladies and gentlemen, let us go have some information to collect. Okay? Okay. So, ladies and gentlemen, let's start with something simple. Time is a fleetin', but we'll start with something that we've done before. I'd like you to go down to the analysis area here. Okay? And into the parameter variation experiment. Mind you, I'm in there. I would like you to drag in a histogram data object. And this is going to say nurses utilization, histogram data. Okay? And now I'd like you to drag in a histogram object from the bottom of analysis. Okay? And for this histogram, I would like to call that nurses utilization histogram. And the most critical thing that we want to do is we want to do in the data area. So what did I do? I added a nurses utilization histogram data. I just created that. And I said, and I didn't change any of its components. I then went to here, to this, I dragged in a histogram. This was a histogram data object. I dragged in a histogram. And for the histogram, I went, ladies and gentlemen, and I called it nurses utilization histogram. And I want to add histogram data here. And for the histogram, I want to say nurses utilization histogram data. In other words, I want to point it to, I want to vector it to, I want to direct it to this histogram data object. Okay? So this histogram will show the data that's being accumulated here. Now, build your model. Make sure it's a happy camper. Okay? Mine is uncharacteristically failing to indicate its current happiness. Okay. Okay, are you ready to go? Do you want another minute? Who wants another minute? Okay? Okay. Okay. Okay, now, let me ask this then. Well, if I ran this model, would it actually do something meaningful with this histogram? What haven't we done yet? Well, we've not told anything to put data into this. So let's do that. Okay? Are you ready? Okay. Watch this. Watch this. So, I'd like you to scroll back down to where it said after simulation run. Okay? And what I'm going to do after simulation run, I'm going to say nurses utilization histogram data dot add root dot nurses dot utilization. I'll put it up for the benefit of the class on the big screen. Okay. Notepad. Hey. Okay. Okay. Here you go. That's what I did. So what am I doing there? Someone please decode this for me. What have we done? After each realization, each simulation run, I'm doing this. What is root? Main. So I'm asking, what is nurses within main? It's the resource pool, right, of nurses. And we're asking, give me its utilization, and then we're adding that to the histogram data object that we have here. Where is this histogram data object? Is that main? No, it's right here. It's in the experiment. So we are, after each simulation one, we're salvaging this data from that particular realization, and we're putting it into this histogram data object. Does that make sense? Okay, ladies and gentlemen, I'm going to run this. Okay? Showing a very, almost no variability here. 100% fell within that range. Okay, well, that's great. I would have liked more detail. Okay, initial interval size. I'm going to make an initial interval size 0.01, and I'm going to say a fixed range between 0 and 1, and I'm going to have 100 intervals in that range for this histogram data. Okay, 100 intervals in that range between 0 and 1. And I'm going to run it. So where did I do that? I did it in the histogram data. I said fixed, and here we go. Okay. Okay, they're all falling. Man, they're all falling in that region. Okay. 1,000 intervals. Man. Better yet, what's that? 3 nurses in 5 rooms. You're right. So let's do it with, good point. Arlen hit it exactly on the head. Time is a-fleetin'. I will leave you to sort out the naming. Let's, instead of doing nurses utilization, let's do room utilization, right? So instead of doing nurses, let's do root dot procedure rooms dot utilization. Thank you, Arlen, for that observation. Most valued. Okay, so let's run that. And now you can ignore this component here. Okay, it's still, it looks like it's It's all going, I mean, there is some variability. Take a look at it here. But it's between 0.595 and 598. I mean, it's just totally pegged within those values. Okay, but the point is we got data out, it's here. So now, in the coup de grace, in the culminating moment of this class and of your need to address problem set 3 and problem 3 on that, let us now do something we have never done before. Okay? We're going to do two things. Mark my words. Number one, let's go back to main. And ladies and gentlemen, I want to go and I want to create a data set in main. A data set is a construct that will allow us to save data over time. And this is going to be called procedure room utilization data set. Okay? Great. Procedure room utilization data set. It is going to keep up to 100 samples. It will update data automatically. Watch that. I just dragged in the data set from analysis. I scrolled down. I call it procedure room utilization data set. I said update data automatically, and I left it at the default settings. Every 1 hour, it's going to update the data. Okay. Okay. And what data will it use? Watch this. For vertical axis value, I want to enter procedure rooms dot utilization. So every hour, this data set will save away a value of what fraction the procedure rooms are in place. Are you okay with that? Okay, ladies and gentlemen, just to show you, you don't have to do this, but I'm going to run the simulation, and you will see this guy here accumulating values. See, it says 3 samples, 4 samples, 5 samples. This is the traditional one, and notice here's the utilization being printed out. Do you see that? Okay. Ladies and gentlemen, you are in problem 3 going to be defining a similar data set. It'll be recording over time certain values, like the fraction infected. Okay? That lives in main. I want to strongly emphasize that data set is living in main. It's sampling from the utilization of these procedure rooms. Okay? Are we clear about that? This data set is in main. Now, and this is key steps, I'm going back to the parameter variation experiment. And I am going to add 2 constructs. Construct 1, a histogram 2D data. And this is going to be like a 2-dimensional histogram. It's going to have histogram and X values for time and histogram and Y values for the value to be considered. And we're going to have each bin is going to be divided up for a certain time and a certain number of people and a certain procedure room sort of level of use. And it's going to have a greater number of values in it, 1, 2, 3, 4. For the number of times it's seen that across all the realizations, all the 100 realizations. So here, for the data, I'm going to have procedure room utilization histogram 2D data. Look, we know it's a histogram 2D data for procedure room utilization. Great. Okay. Excellent. So that's step 1. Step 2 for this guy is to define intervals for the X value between 100 intervals, that's 100 time points, and it's going to be a range between, and I'm going to set this between 0.5 and 0.6, okay? 0.5 and 0.6. Excuse me, 0 to 100, what am I doing? 0.5 and 0.6 will be for the Y values, the actual values there, okay? 20 of them from 0.5 to 0.6. Make it 100 of them from 0.5 to 0.6. Okay? 100 of these guys. So this is going to be a two-dimensional histogram. Divided up, not just the traditional histogram we saw before would be something like this. It would count the number of times a given something fell within a given range. So maybe this one, it had 3 times it fell here. This one, it had 8 times, right? It fell within this range. You've seen this before, histograms? Now we're having as a 2D histogram. This is time, and we have bins here over time. And here we have values here on the y-axis. And this is going to define a grid, right, like this. And each of these grid cells is going to have a count in it, the number of times that during this time interval we fell within this range. So this is going to be like 3 times here. Maybe this is 5 times within this time interval it fell within this range. Does that make sense? One is left to wonder. Okay, so we're getting close to being done, which is good because we're getting close to being out of time. Okay, next. So that's a histogram 2D data structure. Next, I'd like to drag in a histogram 2D, no less. A histogram 2D. There we go. And this one will be called something very close. This was the 2D data on which it will depend. Here, the histogram 2D, it's going to be called the same thing but without the data at the end. And we're going to say show bins, add histogram data, and we want to add in a pointer to this histogram data, okay, to this guy here. Remember, autocomplete, ladies and gentlemen, is your friend. Procedure room 2D data. That's what you want there, okay? Okay, now we're almost done. We have just one thing left to do. What is that? We have to tell it to add that in. Okay, now, this is where all the things come together. I was going to say where all the chickens come home to roost, but that isn't quite what I mean. Okay, ladies and gentlemen, remember we created, not 5 minutes ago, we created a data set here in Maine. Do you remember that one? It was accumulating over time. Do you remember that? Now, that lived in Maine. I cannot stress that enough. It lived in Maine. In the parameter variation experiment, if you scroll down to that area after simulation run, okay, oops, I'm looking at the wrong one. If you scroll down to after simulation run, we will then add that data set into the 2D histogram data set. So, watch this, ladies and gentlemen. Procedure, well, not watch, do this. Procedure room 2D data dot add into this 2D data structure. Even that isn't 10 meters a second. We're adding this, right? We're adding that thing in. Okay. We're going to be adding the data set from Maine. Procedure room data set. This is the data set we have in Maine. Remember it? It's right there. We just added it. Remember, this is recording every 1 hour. It's recording this utilization. Remember that? One hopes so. In the parameter variation experiment, that is in fact what we're adding into the 2D data object. Okay, and it will be plotted on this histogram. Okay, so watch this. Let's run it. And, okay, so, okay, great. Okay, so why mumble? Okay, why isn't that displaying it? Okay, this is not favorable, but give me just a second. Okay, so I'm investigating hypotheses. What could be off? First of all, is it giving data that falls in the range? Let's go run the single simulation. So one hypothesis is that maybe I mistook the range. It shouldn't be from 0.5 to 0.6. Let's go look here, 0.593, 596, okay. Looks fine to me, okay. So it looks like this data set does indeed have values that lie in that range. So I don't see a big problem with that. Look at this. It's just filled that. It all goes to 0.6. That is suspicious, but we're only running at 100 time units in this parameter variation experiment. So I don't think that should matter. Okay. So I'm going back to parameter variation experiment. I'm going to set it, just to hedge my bets, to be from 0.5 to 0.7. Okay. Let's go to data update. It is updating data automatically. That's good. Okay. And I'm going to run this to see did I actually fix that problem. It's still getting none within that area. Okay, so why not? Why not? Okay, this is getting unfortunate. It should work. Does anyone see data appearing on this guy here? Yes, you do. 2 people. Okay. Okay, the plot thickens. Does anyone know what? I must have screwed something up in doing this. Does anyone, did you notice anything that was different between yours and mine here? No? No? Okay. Because it should be, I don't see anything that's wrong about this. Okay. Let's try this. Sorry. I have a theory, and we need to get out of this room, but this is still not going. Okay. It's still not this 2D histogram data. Okay. Okay, ladies and gentlemen, we're going to have to abandon the room here. And I apologize. I will send you mail about how to resolve this issue. There's evidently some small thing wrong here, and I'm not sure what... Oh, I got it. Sorry, folks. Number of intervals, the x-axis for this, I said verbally 0 to 100, and it should be 0 to 100, not 0 to 10 for this x value. I bet you that's it. Watch this. Bingo. Bingo. Okay, you got it? Here, okay, here, number of intervals in the x-axis, I had mistakenly left it 0 to 1. It should have been 0 to 100. If you fix that, you should see displayed in all its manifold glory this 2D histogram. Each of these bins by darkness indicates how many cases fall within that region. This lower one is lighter because few cases fall in that region over time. The upper ones are darker. You could see they cluster around a certain point. And that, ladies and gentlemen, is nothing less than a thing of both of beauty and of utility for you finishing your problem set. I hope that was useful. I will share this model as I am wont to do, and I will share this video, and I will provide another video as well. Thank you very much. And have a good break for next week and a good holiday. I do that all the time.